Hey guys, Mr. B here, bringing another math video. This video is on solving trigonometric equations in transformational form. So we've already done solving typical trigonometric equations where all you've seen is something here inside where theta would normally be. So it might be just theta or x. With something in transformational form, of course, it has all the parameters of a transformation, a, b, h, and k, which makes it slightly more complicated to be able to solve because there's more stuff going on. So that's what we're going to do today, and hopefully it makes a little bit of sense to you. Alright, so before we do that, we got to do a little review of the Casserole. So we're working in radians today, so I'm going to do the Casserole in radians. If anybody doesn't remember the Casserole, basically the Casserole gives us the quadrants where each trigonometric equation is positive. So C means that cos is positive in quadrant 4. A means everything is positive in quadrant 1. S, only sine is positive in quadrant 3. And T, only tan is positive in quadrant 1. Now, with the Casserole, I always like to add in my rules for my reference angle as well. So, in quadrant 1, theta equals theta r. So, whatever your reference angle is, it's going to be the same as your actual angle. I'm going to try to change my pen. See if that works. In quadrant 2, theta is pi minus theta r. So you got, normally that you might be used to seeing that as 180, but we're working in radians. That pi is the same as 180. And in quadrant 2, it's pi plus theta r. And in quadrant 3, it's theta is equal to 2 pi minus theta r. So now that we know this, and if you're doing a test or anything like this, this is something that is definitely worth studying. Now that we know this, basically our goal is to find this reference angle first. So then we can figure out what's going on in all the other quadrants. So here's an example. So we've got solve all values of x in radians, and we're given cos, and we're given this complicated looking thing. So you can see here that we've got something inside this normally where theta would be. And luckily for us, it's already solved for my ratio, so there's nothing to do at first. That's our goal at first, is to be able to get cos by itself equal to a number. So because this is so complicated, what I like to do is I like to call that big complicated thing m. And I go 4x minus pi over 2 is my m value. So that entire thing inside the cos function is m. So now I can rewrite my cos, and I'll replace that big thing with m. And that's going to be equal to negative root 3 over 2. So now I can go ahead and solve for my reference angle, and it's something very simple. All right. Another thing I always want to note when I'm doing one of these questions is I want to know what my b value is. So my b value is always inside the function, and it's always in front of your x. So then it's either outside of brackets or directly in front of your x. So b is equal to 4. So that's really important, and I'll explain why that is. Now, if you think back to when we did graphing, you might be thinking, well, what does b affect? Well, b affects the period, and I'll see how that plays in a second. So the first thing we're going to do is we're going to find the reference angle for this. So we're going to have to use the inverse trigonometric function. So normally we might have wrote theta r, but for this guy I'm going to write mr. So like the reference angle. It just happens to be m this time. And generally it always will be for this type if you use my lettering. So cos negative 1. Now remember a rule when we're finding the reference angle, easily forgot on a test, that whatever number I put in here, it's always plus. This negative is basically for the Casserole, right? So it'll tell me what quadrants to actually pick where cos is negative. So now all I need to do is I can evaluate this. Maybe you know those off by heart. That works out even better. So cos negative 1 root 3 over 2, and I end up with pi over 6. So that's my reference angle right there. So now I can actually go to my quadrants to be able to find my values of m. All right. So if I look at this, Casserole, right? I'm looking for where cos is negative. So cos is positive. Well, actually, I'll just flick back to the rule. Cos is positive in quadrant 4. Cos is positive in quadrant 1. So it's in quadrant 2 and 3 where cos is negative. S and T. Only sine here, only tan here. So my rule for quadrant 2 is m. Now it's very tempting to want to put theta there. You got to keep the same variable the whole way through. So m is equal to pi minus mr. So that's going to be pi minus pi over 6. And then we can do the math on that. So that's 5 pi over 6. And then in quadrant 3, and remember that's m equals, we get m equals pi plus mr. Try to move this thing up a little bit. And that equals pi plus pi over 6. And that guy equals 7 pi over 6. So now, and that's an m value as well. So now what we need to do is recognize, well, we're not actually looking for m, we're looking for the values of the x, right? So that's what we want to find, this original x that was here. Well, that original x is over here. It's hidden away. So what we need to do is we got to do a little algebra. We have to take our values of m, sub them in here, and actually solve for x. So I'll do it for the first one. So it's 5 pi over 6. So it'll be 5 pi over 6 equals that mess that was inside. So 4 x minus pi over 2. Just like that. So now I need to be able to solve this thing and make my life a little bit easier. So the first thing I'll do is I'll divide both sides by 4. Get rid of that 4 right there. So I'll just divide both sides by 4. I got a plus sign. This is going to mess everything up, watch. So my eraser's going to get stuck on a bit. Here we go. Let's try that. And divide by 4. We're good. All right, so this turns into 5 pi over 24 equals x minus pi over 2. All I need to do now is add pi over 2 to both sides. So there's a lot going on with this stuff, right? So I get x equals, and then I'm just going to go straight to my Casio, 5 pi over 24 plus pi over 2, and end up with 17 pi over 24. Let me erase that. All right, 17 pi over 24. So there it is. So certainly not the easiest thing to do in the world, and we actually have to do it again, right? Because we got two m values. M over there is 7 pi over 6. So I'll do the same thing. I'll take that 7 pi over 6, sub in for m, and solve. So 7 pi over 6 equals 4 x minus pi over 2. So the steps are mostly the same, right? So it's just divide by 4. And again, I'm relying on my Casio and my mental math. So that becomes 7 pi over 24. And that equals x minus pi over 2. Add pi over 2 to both sides. Just like that. And then we end up with x equals, so let's do a quick check, should be 19 pi over 24, I do believe, but I'm just going to double check for the video. I don't want to make a mistake. I'm not in class now, so I don't want to risk my mental math. Yeah, so 19 pi over 24. So that's my two solutions. Now, are we done yet? So the answer is not quite. So that's my two solutions that the Casserole will give me. we have to actually put this in a piecewise function. So it says solve for all values of x in radians. So that means we have to do a piecewise function. So this is where this b guide comes in handy. So normally what we would do with a regular cos function or sine function to do piecewise is we would add and subtract 360 degrees, because that's, or 2 pi. That's what our normal period of sine or cos would be. However, when we have a b value, that changes the period. So it actually could make it repeat more often, or it could repeat less often. So we need to be able to find that period in order to know what to add and subtract in the piecewise function. So it's a really simple question to work out. So over to the side, I'll just do the period. And I'm running out of space. So the period is always very simple, 2 pi divided by your b value. So 2 pi divided by 4 is pi over 2. There it is. And that's my period. That's what I'm going to add and subtract. So I'll go all the way down here, and I'll write my piecewise function out. So my x, and I'll do my little squiggly bracket, 17 pi over 24, and then 19 pi over 24. Try to do biggest, smallest first, and then we're going to do, now, so there's a couple different ways you can do it. You can do plus or minus, or just plus. So I'll do just plus today, and then it's my period. Okay, so pi over 2. And then I'm going to use some type of variable. So some people like to use k. I always use n. And then depending on, since I'm only using plus, I need to represent all the minuses with my number set. So I'll say n belongs to z, which I use as integers. Okay, you can use I too. Some teachers don't really care. Then we'll do the same thing. Pi over 2 n belongs to z. So you could also do this plus or minus pi over 2 n, and then n belongs to w. My students prefer this because it's easy to remember, new. So whatever you like. So that's my answer for all radians. So you can certainly see that there's quite a lot to this question. So it takes a bit of time to master them. So practice these 2 examples in the class, and I'll see you guys in class hopefully soon. Like, share, subscribe, and I'll talk to you later.